Hopefully you've had a moment to kind of play with this a little bit and see that these two are similar to one another. And we know that they're similar to one another because we're told here at the top that angle C and angle G are both 98.54 degrees. Angle A is congruent to angle E, and angle B is congruent to angle D. And we know that from our previous lesson, angle, that if the angles are congruent to one another, then the triangles themselves are similar. So we know they're similar to start with. And what we have here is we have the ratios of corresponding sides, GD, so this side here, GD, over its corresponding part, CB, and we have DE over its corresponding part, AB, and then finally the last GE over AC. And when we do that, we see that we get the same value every time. That value is the scale factor. And so if we have similar triangles, then those ratios are all equal, which means their side lengths are proportional. And I can play with this a little by changing the size. I can change the shape of them, really. That's not changing the size much, but I could change the size of the larger one by sliding this R here. Notice my scale factor is changing, but it's the same everywhere. Or I can change the shape. I can grab a vertex over here on the little guy, move it around so that it's a different shaped triangle, and the scale factors are remaining the same. I can spin it around here. So this is a nice illustration of no matter what kind of triangle you have, doesn't have to be any certain kind of triangle. This happens to be an acute scalene triangle.